Okay, good afternoon. This is Mr. Rongan. I'm going to teach you something on data structures and algorithm lecture 1. So now let's look at the course outline of this program. We are going to look at the introduction to data structures. We'll cover algorithms, recursion, the stacks, the queue, list and linked list, the trees, the sorting, searching, the graphs, and also hashing. So this is the content of the entire program that we're going to cover as we consider the data structures. But today, let's look at the introduction to data structures. And we're going to begin with the abstract data types. First of all, what are the data structures? What is data structure? A data structure basically is a representation of data and operation around on the data. So when we talk about the data itself and the functions that will operate on that particular data, then you come up with what we call the data structure. So it encapsulates or covers two things. If there's data and there's also operations working on the data, then what you have is the data structure. So a data structure is a way to store and organize data in order to facilitate the access and the modifications. Want to access the access and the modifications of data, then you have to basically access what we call data structure, which will help you to organize and also access the data. So now the data structure methods that are basically used to do this, they are logical in nature. Okay, because you're saying data structure are the method of presenting of logical relationships between individual data elements related to the solution of the given problem. So simply put, when you say data structures, you're referring to how you access the data stored in it and how those methods will be operating on the data to solve a particular problem.
My dear, you have a text message.
So as we look at data structures before, now let's look at the structure of the two categories that we're going to focus on. Okay, what are these two categories? We'll look at the linear data structures, which are static in nature, and this includes the arrays, linked lists, stack, and the queues. These are static in nature. They don't change the size as you execute them. And then we've got others which we call non-linear data structures, which are dynamic in nature. They change the structure, the size of the structure as we execute them. So as we discuss the basic data structures, we focus on the two classifications, that is the linear data structure and the non-linear data structures. So for instance, we've got the arrays there on top, which are fixed, as you can see. This structure is fixed. It cannot grow, it cannot reduce as we execute the program. But as you compare it with the one below, which is dynamic, this data structure can grow. Okay, it can reduce in size, it can also increase in size. What does it mean? If I want, I can remove one node here, the size will reduce. If I want, I can put more nodes in front, still the size will increase. So this is dynamic structure. It can change as the program is able to execute. But this one is static. It will never change when the program is running. Apart from these examples that I've used here to differentiate the two structures, we've got the stacks, which are also static. We've got the queues, which are also static. But for the dynamic one, for the trees, these are also dynamic. Right. So now the selection of data structure is a choice of particular data model depends on two considerations. What do you consider? It must be rich enough in structure to represent the relationship between data elements. And then the structure should be simple enough that one can effectively process the data when necessary. So what does this mean? It means that if you're choosing the data structure, make sure that that data structure will give you a clear-cut relationship between the data elements and the functions, right? If it won't have that clear-cut relationship between data and the functions, it's a very bad structure. And also, if that structure is not effective when it comes to access or process data, it's very bad. Where to find data and how to access data and where to store data. If it is giving you such problems, it's a very bad structure. So this tool has to be rich. Okay, the access has to be rich, and the presentation has to be rich. It makes a good structure. Types of data structures. What are the types of data structures? As we earlier mentioned, we've got linear. In linear data structure, values are arranged in linear fashion. The values are arranged in linear fashion. What does it mean? Okay, linear simply means line, from the word line. So we expect something to be arranged from one point to the other point, right? The line is the distance between 2 points. So if there were point A, point B, point C, point D, that arrangement fashion, then that is called a linear structure. So this is where you find fixed structures such as an array, the one that I'll show in the next lecture, or to implement arrays. And also, we've got linked lists. These are dynamic ones. Okay, these ones are adjustable. They are linked. You can remove one node, put one node, just like that. Their structure is not always fixed. The stacks, the first in, first out, you add on top, you remove from the top. The FIFO structure, these ones are also fixed. And then the queue, okay, or rather we said the stack are LIFO, okay, last in, first out. But the queues are the ones that are FIFO, first in, first out. These are also fixed arrangements. We've got priority queues, okay, which add anywhere, remove the highest priority. So with a priority queue, you can actually add anywhere as opposed to just a queue. You have to add from the rear, the behind, and then you move from the front. But for the priority queue, you can add anywhere and to move according to the number of rows that is assigned to a particular data you want to remove. So all these we'll see them as we discuss the algorithms later on. But in the meantime, let's focus on what they're able to do. Okay. Now, what about the types of data structures which are non-linear in nature, the ones that are arranged, okay, in any order? There's no point A to point B clear distance. They are arranged in any order as long as there's interconnection. So these are the ones that we find in hash tables, where you can insert and search anywhere. The data arrangement is not in any order. For the trees, where data is organized as branches, you know? Data, just like a tree, you turn a tree, okay? The branches are below. So you see how data will be organized in that manner. You don't have to have from point A to point B, and the data is dependent on the previous instruction, no? What it is, they can branch anywhere. A graph is more general branching structure, which less restrict connection conditions than for a tree. So a graph is more complex as compared to a tree. Basically, what you're saying is all these are examples of non-linear data structures. So now the types of data structures continuous. We have seen another type, the third one, which we call homogeneous types. So in this type of data structure, values of the same type are stored. These are examples, okay? Arrays. Arrays are the best examples of homogeneous data structures, where you can only store same data types, nothing else. Homo means same, right? So if you say homogeneous, we are referring to something that is similar. So as we discuss the arrays, we look at how we can actually store data which are only same type. For example, if you're storing integers, you can only store integers, nothing else. If you're storing the strings, you can only store strings, nothing else. Then of course the non-homogeneous, which we can also call heterogeneous data types. Now the heterogeneous data types in this type of data structure, data values of different types can be grouped and stored. So it depends with the language that you're using. If you're using Pascal, of course, you use records to do that. In C++, you can use structures. Java, of course, you can make use of the classes to do the heterogeneous or homogeneous data structures. Right. Now let's move on to abstract data types and data structures. When you say abstract data types, these are types that can be defined by the user. These are user-defined data structures. Basically, we have these types, okay, as a result of instantiating an object from a particular class, or you've got a structure that you have defined as a data structure, and then from there you can come up with a type of that structure. So abstract data types, the ADTs, store data and allows various operations on the data to access and change it. So mathematically speaking, you can say the abstract data types basically is a collection of data and associated operations for manipulating that data. Then you've got other data structures, okay, we're still looking at the abstract data type. Basically, they can be implemented by using classes and structures. In Pascal, okay, we can use records to come up with abstract data types, or the ones that can be, okay, instantiated from the class. Those are examples of abstract data types. So these can be abstracted, encapsulated, or hidden, actually hidden. So now if you look at these pillars, abstraction, encapsulation, and information hiding, these are the pillars that we discussed in object-oriented programming, which indicate the principle or simplify or specify the principle of object having data and method put in one software unit. So even the data structures, they are the ones that makes use of encapsulation very well. Data hiding, yes. With abstract data structures, you can only get, okay, or give out what is necessary to the users and hide the rest, okay, the implementation. That's what we call information hiding. So as you can see, abstraction is a structure for problem solving where we will define entities, have got data and abstractions which are only relevant to a particular problem domain. So those that are irrelevant are not part of the problem domain. So the principles of hiding normally uses data structure to provide well-defined interface, and this is called encapsulation. Okay, so to encapsulate, the direct translation is to put things in the cup, all right, in cover. So what do you put in the cup and cover it? We of course put the data and operations in one software unit, which we are referring to as the data structure. The core operations of abstract data structures. Okay, one of them, okay, the collection of ADT should provide a way to add an item. So if you want to add an item, you can use ADT, remove an item, retrieve, process, even find. So it has many more possibilities that we can talk about, such as a collection of empty data structure, make a collection of empty data structure, or you can actually have a subset of that collection of data structure. You'll see in the implementation. So no single data structure works well for all purposes. So it is important to know the strength and the limitation of several of them. For example, stacks. As you can see, collection with access only to the last element inserted. So what is last in first out, as you can see. And it has two algorithms which are popularly known as what? The pop for removing and the push for putting data inside. The queue basically is a pure collection of the FIFO, first in, first out, right? Where you insert from the rear and get from the front, right? And then a list is flexible, it's dynamic. You can insert data anywhere, you can read data at any position. Okay, so these are called lists or pointers. A tree is a collection of elements called nodes. Remember, these are non-linear. You can actually insert or create a structure at any position, right? And you can branch at any position according to the main node, which you call the parent node. All right, so for today, we have just run through the activities of data structure. So now in the next lecture, I'm going to show you how to implement some of these data structures that I've looked at using perhaps C++, or Java, or any other language. So C, the language you're going to adopt as we implement some of these suite of codes or algorithms. Thanks very much for watching. Make sure to subscribe to watch more videos on ICT.